All right, let's talk about one of the most powerful technologies out there, something that's quietly shaping almost everything we do: machine learning. It is the hidden engine behind so much of our daily lives. So let's peel back the curtain and really get a look at not just what it is, but how it actually works. I mean, think about it for a second. You finish binging a series, and boom, almost like magic, Netflix serves up your next obsession. It really feels like it's reading your mind, right? Well, spoiler alert, it's not magic. It's a fantastic application of machine learning. And honestly, it's the perfect place for us to start. Okay, so let's use Netflix as our main example here. We're going to see how this one system manages to personalize what you see on a scale that is just massive. And when I say massive, I mean it. Check out this number: 270 million users. Netflix is personalizing the experience for every single one of them. That means practically no two homepages on the planet look the same. Every time you log in, this incredibly complex system kicks in and in milliseconds tailors that screen just for you. Wild, right? So how on earth do they pull that off? Well, it pretty much boils down to a three-step dance. First up, step one is something called candidate generation. The system looks at thousands of movies and shows and narrows it down to a few hundred that seem like a good fit based on your watch history and what other people with similar taste are into. Next, step two is ranking. Now, each of those shows gets a personalized score, kind of like a grade, based on all sorts of things, like what genres you tend to finish. And finally, step three, re-ranking. Now this is the secret sauce. To keep you from getting bored, it shuffles the deck a bit, adding variety and new stuff so your homepage doesn't feel stale. It always feels fresh. That whole Netflix system is the perfect setup for the huge idea behind machine learning itself. It is a completely different way of thinking about how we tell computers what to do. Okay, get ready, because this right here is the big aha moment. With traditional programming, a developer, a human, writes a set of very specific step-by-step rules. You give the computer some data, it follows those rules exactly, and it spits out an answer. Simple enough. But with machine learning, we flip that whole thing on its head. You give the machine the data, and you give it the correct answers. And you tell it, hey, you figure out the rules. The output isn't just one answer. The output is a whole new program, what we call a model, that has learned how to find the answers all by itself. So, when you boil it all down, that's what we're talking about. Machine learning is all about creating systems that learn from data. They find the patterns, and they make decisions on their own. Instead of a human programmer trying to think of every single possible rule, we let the machine do the heavy lifting and discover those rules for itself. So, if we're going to teach a machine, what do we actually need? What are the building blocks? Turns out, it all comes down to a few key ideas that are way simpler than they sound. All right, the most common way to do this is called supervised learning. And the absolute best way to think about it is like this. It's like a student studying for a big test, but they have the answer key. You give the machine a giant data set where all the correct answers are already included, and its job is to figure out the connections between the questions and those answers. Now, for this to work, the machine needs two key things. The first is called a feature. A feature is really just a clue. It's a single piece of information from the input data. So, for example, if you're trying to predict the price of a house, a feature might be its square footage, or maybe the number of bedrooms it has. And on the other side of that coin, the second thing it needs is a label. The label is just the answer key. It's the outcome you want the machine to learn how to predict. So, in our house example, the features are the square footage and number of bedrooms. And the label, well, that's the final sale price of the house. See? You're teaching the machine to predict the label using the features. Let's make this crystal clear with a super simple analogy: a coin sorter. Imagine you have a giant bag with a million different coins. Okay, for each coin, the feature, the clue, is its weight. And the label, the answer, is its currency, whether it's a rupee, a euro, or a dirham. You feed thousands of these examples to the machine, and it starts to learn the rule, like, if a coin weighs about 3 grams, it's almost always a rupee. And once it learns that rule, you can give it a brand new coin it's never seen before, and it can predict the currency just by weighing it. That's it. So, we've been throwing this word model around a lot, but what does a model actually look like? You know, under the hood. Let's take a peek at one of the most straightforward and intuitive types of models out there. And that would be a decision tree. The reason these are so great for understanding this stuff is that they work a lot like our own brains do. When we make a decision, we tend to ask a series of simple, cascading questions, and that's literally all a decision tree does. Okay, let's just follow the logic on this one here. The goal is to predict if a friend is going to play football. The model's first question is, what's the weather outlook? Let's say it's sunny. Okay, It follows that path and moves to the next question. What's the humidity? If the humidity is less than 75, the prediction is yes, they'll play. See? It's just a simple flowchart of questions about the features that leads you step by step to the final answer, the label. But, life is usually a lot more complicated than one simple flowchart. A single decision tree can make mistakes. It can be wrong. So what does machine learning do when problems get a little more complex? Well, it builds a team. Instead of relying on just one decision tree, we can use something called a random forest. And that is exactly what it sounds like. It's a whole collection, sometimes hundreds or even thousands, of slightly different decision trees. Each tree gets to look at the problem and make a prediction. It gets a vote. Then the final answer is just whatever the majority decided. This whole wisdom of the crowd approach turns out to be way more accurate and reliable. So now that we've got the basic building blocks down, features, labels, models, let's zoom way out. Because once you know what you're looking for, you start to realize these systems are absolutely everywhere. And I mean everywhere. Think about your day. When YouTube suggests the next video for you to watch, that's machine learning. That Discover Weekly playlist that Spotify makes just for you. Yep, that's ML. Your bank sending you a text about a suspicious transaction. Machine learning. Unlocking your phone with your face. Amazon recommending a product. Uber and Lyft's surge pricing. Even weather forecasts and analyzing medical scans. It's all powered by machine learning, constantly working in the background, finding patterns. And really, that brings us to the most important point of all. Why do we even need this? We need it because machine learning can find incredibly subtle, complex patterns in just mind-boggling amounts of data. Patterns that would be pretty much impossible for any human, or even a team of humans, to ever spot, and then write down as a set of rules. That is its superpower. So I'll leave you with a question. Now that you can see the basic pattern, that machine learning is all about finding rules in data, where are you going to spot it next out in the world? Keep an eye out. Thanks for tuning in.